This is Geometry, Lesson 8-1, Finding Trigonometric Ratios. I'm your host, Mr. Sindel. Let's first dive into some right triangle vocabulary. So whenever you have a right triangle, you have the ability to use what's known as trigonometry. If you cannot pronounce trigonometry or trigonometric or any of these words, you can just say trig for short, and that's totally fine. So whenever you have a right triangle, usually we have some sort of angle that we're talking about. We call that the angle of reference, and it can change. It's never the 90-degree angle, but it is one of these other angles. So in this case, if I'm looking at example 1, the angle of reference is A. So this is where my theta would be. This angle, by the way, is known as theta, this Greek letter that usually indicates that we have some sort of angle. And sometimes it moves around. Like in this case, I'm talking about this angle A. In this case, I'm talking about this angle C, the angle Z, the angle R. It really depends on what angle I'm talking about, and that will change what the vocabulary in the triangle is called. So just like before, we have this length right here, which is known as the hypotenuse. So let's go ahead and label that. Hypotenuse. How do I know it's the hypotenuse? My old definition is it's the slanty one, but a better definition is it's the side length that is across or opposite of the 90-degree angle. So opposite of this 90-degree angle, I go across, and there's the hypotenuse. Let's go ahead and label this one as well, hypotenuse. So the hypotenuse is one of those the side lengths that doesn't really change depending on the angle of reference. It's always going to be across from the 90-degree angle. So the other two legs, is what we called them before, they actually have names now that we're talking about a specific angle. If I'm talking about this angle, on the opposite side of this side is known as the very creative name opposite. But notice how if I'm labeling the opposite over here, it changes when the angle is changing to up here. Now, if I'm going on the opposite side of this angle, I'm actually talking about this side length, and that one is now the opposite, even though I have the same triangle. All right, and then we just need the other leg's name, and we need a name that basically says I'm not the hypotenuse, but I'm right next to the angle. I'm like the neighbor of the angle. Well, another way of saying neighbor is the adjacent, meaning next to. So it's not the one that's the hypotenuse, but it's the other one that's next to, so adjacent. So we labeled this adjacent. And again, when I'm looking at the first triangle, the leg right here that is next to the angle that's not the hypotenuse is the adjacent leg. Adjacent. Cool. So now you have all of your vocabulary. Just be careful with that angle of reference. And now it's kind of time to talk about where trig ratios come from. Like, why do we have these things? Like, what are they? So let me go ahead and make a new page here. So back in the day, we noticed that whenever we had a triangle, let's go ahead and just make up a fictional triangle and say that this angle down here is like, I don't know, 43 degrees, and it was a right triangle. And we saw another triangle over here that was way, way bigger than this. It was dilated. So it was actually the same 90-degree angle, the same 43-degree angle, but like way bigger, right? We noticed that whenever we took, we'll call this one H for hypotenuse, and we'll call this one O for I don't want to be confused with 0, so let's do A for adjacent. We noticed that when we take fractions, if I look at the fraction here of H divided by A, it happens to be the same exact fraction as this one, H divided by A. It's always the same regardless of the size of the triangle. And it turns out it's really, really useful to give this specific ratio a name. And I actually don't know exactly the history on why it's called this, but we said, hey, let's go ahead and call this ratio a special thing. Let's call that the cosine. So cosine is just a fancy name for it. It's always a ratio of these things. And it's when you have similar triangles. These triangles are similar because I have two angles that are the same. Therefore, the third angle is also the same. And I'm just dilating the triangles. So we'll talk about why it's a little bit more useful later, but for now, I just want you to practice using vocabulary. So let's go ahead and figure out what all of these are. And before I talk about what these fractions are over here, these ratios, let's use this other word. I like the word ratios here. I'm going to cross this one off and say fraction. The better word is ratios. They're the same thing though. So whenever you see this in the textbook, it's not spelled out sine because mathematicians are lazy. We only want to write 3 letters, so we're just going to write sin. So a lot of students make the mistake of saying, well, this means sin. Well, no, no, no. You actually pronounce this 3-letter word sine, even though you're too lazy to write the E. And same thing down here. The 3-letter abbreviation for cosine is COS. The 3-letter abbreviation for tangent is TAN. And again, you don't read this as cos. You read it as cosine. You don't read this as tan. You read this as tangent. All right, so what is sine? Well, sine is the ratio, the fraction of the opposite divided by the hypotenuse. So it is a lot to write, but I'm going to go write it in here. It is the opposite in the numerator and the hypotenuse in the denominator. That E is a little bit funky. Let's go ahead and rewrite that. Still funky. Come on. There we go. Where cosine is the adjacent divided by the hypotenuse. Adjacent divided by the hypotenuse. And then finally, the tangent is the opposite divided by the adjacent. That's a lot to memorize. So to make this a little bit easier, let's not write all of this stuff. Let's just write the first 2 letters. So we'll say O divided by H, or A divided by H, or O divided by A. So usually the way that we remember this is these and these, but their full definition, the sine is the opposite divided by the hypotenuse. So this is a lot to memorize, and that's why we have a quick way to remember that, and we call this SOHCAHTOA. So whenever I spell out SOHCAHTOA, it's SOHCAHTOA. SOHCAHTOA is how I pronounce this, and you need to pronounce it the same way as me, because you'll see very quickly here, S stands for sine, and it is opposite divided by hypotenuse. You don't pronounce this thing SOA, right? That would be OA, and that would be incorrect. It's so. The only thing that makes the O sound is O divided by H, or like you can't have A divided by H, that would be sa, right? And this is ka. CAH. And again, that sound is really important because cosine is the adjacent divided by the hypotenuse. So that's ka. And then finally, you have toa. Again, tangent is opposite over adjacent. And again, a lot of students will say, well, couldn't you spell toa like T-A-O? Well, I pronounce that tau. T-A-O is tau, where T-O-A is toa. So it is SOHCAHTOA. You got to get that sound right. If you write it like this, it is super easy to memorize what all of this table is trying to say in one simple line. Usually what students do at the beginning of their quiz or their test in my class for this unit, they will write SOHCAHTOA at the very top of their paper, and they will refer back to it over and over again because it is that useful. All right, we got our notes down. Let's go ahead and apply SOHCAHTOA. Let's apply our basic trig. So again, when I'm asking what is sine of A, you have to first identify, okay, my angle of reference that I'm being asked to find. So this is my angle of reference. So sometimes we'll write a theta right here, say, okay, there's the angle, which means you need to start labeling our vocabulary. We're not going to write out the words hypotenuse, adjacent, and opposite. Let's just write out the first letters. So if I go across from the 90-degree angle, the opposite of the 90-degree angle, this one is the hypotenuse. I'm going to label that with an H. And then opposite of our angle is our opposite, and therefore the process of elimination, A is our adjacent for our 3, and we now need to remember, what is SOHCAHTOA telling us? Well, sine is telling us that I need this part of SOHCAHTOA, the opposite divided by the hypotenuse. So I write out, this is going to be the opposite divided by the hypotenuse. I wouldn't actually do this on a test, but this is just for the notes to show you where this is coming from. I would actually just jump straight in and be like, okay, well, the opposite is 4. So I'd write a 4 on the top, and the hypotenuse is a 5. I would write a 5 on the bottom. I would make sure that my fraction is simplified, it looks good, and then I would box my final answer. That's all there is to it. I mean, all of these are just fractions. What is sine of A? Sine of A is this fraction we know as 4/5. And if I scale this triangle to be really, really big, if I did like 8, 10, and 6, and I multiply everything by 2, this is still the same ratio because you would reduce a fraction to get 4/5. Let's try another one. Tangent of C. So tangent of C, I have to remember, okay, so tangent of C, toa. That's tangent is opposite over adjacent. So I'm going to write out here, this is going to be the opposite over the adjacent. And I don't know what the opposite and adjacent are, so I need to label my triangle. Well, I'm talking about C. C is my angle of reference. My theta lives up here. And then across from my theta, on the opposite side, I have my opposite. And then opposite of my 90-degree angle over here, I have my hypotenuse, and by process of elimination, A, my adjacent, is over here on the left, and I'm ready to fill this in. It's going to be O divided by A, it's going to be 3 divided by 4. So I can go ahead and say this is 3 divided by 4. Go ahead and make sure that your fraction is reduced. It is because I gave you some easy problems to get you started, and we move on to number 3. So now the problems get a little bit tricky because the first two problems, these triangles looked exactly like I had up here, but now the triangles are all twisty and upside down and different dimensions, and they get a little bit scary. So what is cosine? Well, if I'm talking about SOHCAHTOA, cosine right here is the adjacent divided by the hypotenuse, a divided by h. This is going to be a divided by h. I need to identify what is a, what is h. So again, I think my favorite way to start is the hypotenuse. On the other side, on the opposite side of the 90-degree angle, this is going to be my hypotenuse. And then what is my angle of reference? My angle of reference in this case is z. And z is my angle of reference. I'm going to put my theta down here. On the opposite side of my theta, I have my opposite. And then therefore, process of elimination, my adjacent side is the 40. And what letters am I asked to find? A and h, 40 and 41. This fraction is 40 over 41. And again, I can't reduce this fraction, so this is my final answer. I promise you will be able to reduce your fraction tons on the homework and on number 4 on this example. So in example 4, sine of r. Let's go ahead and identify my angle of reference. In this case is r, so I'm going to go ahead and label that my theta. And then on the opposite side of my theta, I have my opposite. Let's go ahead and label that the opposite. If I go on the other side, on the opposite side of my 90-degree angle, that will be my hypotenuse. This is my h. And process of elimination, my a is up here by the 10. What is sine? Sine, using my SOHCAHTOA, sine is the opposite over the hypotenuse. So over here, I'm going to write opposite divided by hypotenuse. Okay, the opposite in this case is 24, the hypotenuse is 26, so this is going to be equal to 24 over 26. 24 over 26. And this is not reduced. I can divide both the numerator and denominator by 2, and that turns it into a 12 over 13. And 12 and 13 are coprime, meaning we are done, and we can box our final answer. And I'm realizing that those notes will print outside of those margins, so I need to scooch everything over just a tad here to the left, and now it will print out. All right, that concludes the top half of the teacher notes. Go ahead and fill in the bottom half of your notes, and that concludes lesson 8-1 for geometry's finding trigonometric ratios. Thanks for watching.